Hello everyone, in the series of 8051, today let us discuss about interfacing of DC motor. Let us see hardware section. Required components are, one is our microcontroller 8089C51, that's our controller name, and second component DC motor. So I am taking simple DC motor, and additionally to drive the motor we required motor drivers. So for the DC motors, we have a motor driver named as L293D. That's the motor driver name. Okay. So this is the microcontroller, sorry, DC motor, and this is the microcontroller. Actually, just like that, you can connect the motor two terminals to the microcontroller. But if the motor is running with high voltage device, microcontroller motor is not enough to drive the motor, right? So instead of that, we should give external power supply to the motor driver. We are providing external power supply, and also the beauty of motor driver is we can control the motor direction. We can control the speed of a motor, and also we can control the motor direction. So before connecting and before writing the code, let me describe the working of motor driver. Important concept. So let me show you the image of Arduino 3D. It comes with the 16 pins. You can see enable 1, 2, that means enable line which is used to enable input 1, input number 2. So this is the single motor driver is used to connect two DC motors. So at a time you can run two DC motors with the help of one driver. Input 1, input number 2 are operating one motor which is connected to the lines of output 1 and output number 2. You can follow my cursor, right? And 8th one is VCC, 16th one is also VCC. Left side of the IC handling one motor, right side of the IC managing second motor. Right side also same thing, input number 3, input number 4 are controlling the motor of output 3, output 4. So input 3, input 4 are related to control the motor which was connected to output 3, output 4 lines, and those two are ground lines. So after taking the connection you can understand that. Okay. So now when you are taking interfacing, input 1 and input 2, those two input lines are connected to microcontroller, and motor output lines are connected to the motor. So here directly you are not connecting motor to the microcontroller, you are connecting only, just you are connecting microcontroller IO lines to the input lines of the motor driver. Okay, then output 1, output 2, those two are used to connect motor 1. So if you have one more motor, you can connect the second motor also. So output 3, output 4 are connecting to the second motor, and you can find input number 3, input number 4. Suppose I'm going to connect those two lines to the 4 to second pin 2.2 and 2.3. Those two are connected to input 3 and input 4. Here you can see enable 1, enable 2. 8th pin, 16th pin, both are have to be connected to the VCC and it is representing ground line. Tick. This one. Okay. So 4th pin, 5th pin are ground lines. And actually inside of the motor driver we have a H bridge circuit. Why it is called H bridge means the shape of the circuit like a H bridge, H character. Right now here we have a motor. Okay, so motor one of the end is connected to supply VCC and second end is connected to the ground terminal. Here you can find four transistors Q1, Q2, Q3 and Q4. Right now, so motor, just assume this is the positive and this is the negative terminal. Now out of four switches at a time we are going to close two switches to run the motor. That may be Q3 or Q2 or else Q1 or Q4. So by switching in this pattern, you can run the DC motor in a clockwise direction as well as anti-clockwise direction. So let us see, master positive is connected to the VCC in this path. Now, if I close Q3 switch, transistor Q3, then VCC is connected to motor positive terminal and motor negative is going through Q2 and followed by ground terminal. In order to do that, we have to close Q3 transistor and Q2 transistor. If we close the switches in this pattern, then DC motor starts to rotate in the clockwise direction. In the second case, in case if you close Q1, then motor negative is going to be connected to the power supply VCC, and if you close Q4 switch, then motor positive terminal is connected to ground via Q4. Now if you close Q1 and Q4, then motor is getting the power supply in the reverse direction so that it starts to rotate in the anti-clockwise direction. In case if you open all the switches, then the state of motor is off. So L293D consists of internally two H-bridge circuits. One H-bridge circuit is controlling one motor. So we have total two circuits so that it is driving two DC motors. Okay, and 8th pin, 16th pin are connected to the VCC. So enable 1, enable 2. Those two lines has to be enabled. In order to enable the pins, we have to give power supply for them. So here I have a power supply section. Directly I am connecting enable 1, enable 2 lines to the VCC. So if those two are connected to VCC, then only you can control the motor. You can run the motors. In case if those two are not connected to the VCC, in case if those two are connected to the ground terminal, we cannot run the DC motors. Actually, 8051 don't have inbuilt pulse width modulation concept. There is no module actually. In case if you have pulse width modulation, by using enable 1, enable 2 lines, you can run the DC motor. So by defaultly, you can check out the motor voltage 12 volts, which are the 12 volts operating DC motors. But our microcontroller is giving only 5 volts from the digital lines. So it requires only 5 volts by the 8051, right? So from the external supply you can give 12 volts. Here just I'm adjusting to the 5 volts. You can adjust to 6 volts, 7 volts also, no problem. This is the hardware connection, right? Now input 1, input 2 are connected to 2.0 and 2.1. Input 3, input 4 are connected to 2.2, 2.3. Let us see the concept of H-bit circuit. Enable line. In case if you connect it to the ground terminal, then even if you go, so actually port input number 2 connected to port 2.1, input 1 is connected to port 2.0. So those two, port 2.0, 2.1, which are the digital IO lines, so that you can write 0 or 1. Actually to run the DC motor we should write 0 and 1 like this, just like that. But if enable line is connected to the ground terminal, even if you give any value here, if you give any value here, the status of the motor is stop. Why? Because enable line is disabled, enable 1 is disabled. In case if you connect enable 1 to the VCC, then if you are giving the values in this pattern 0 then 1, then motor starts to rotate in the clockwise direction. Enable line connected to VCC, and now if you change the values as 10, 10, then it starts to rotate in anti-clockwise direction. It is connected to VCC and the values are 0, 0. Then the status of the motor is stop. Okay. So to run the motor, to control the motor, enable line always should be connected to VCC. So in this one, we are not trying to control the speed of a DC motor. Why? Because inbuilt we don't have a fast width modulation. If you go for like a PIC microcontroller, ARM, Arduino, on the board you have a fast width modulations. So that by using them, you can control the motor speed. Right now, so from the input 1, input 2, we should send these values to, in order to run the motor in the clockwise direction, anti-clockwise. If you want to stop, simply by giving 0 and 0 you can stop the motor. So this is the table for only one motor. So same table will be applicable for second motor also. There is no changes at all. Input there you will be getting enable 2 line, input 3, input 4. Then send the same values in this pattern. You can observe the motor direction. Now let's write the code. Just I'm taking the variable name as M1 motor 1 positive terminal, suppose which was connected to port 2.0, motor 1 negative terminal which is connected to 2.1, motor 2 positive terminal connected to the port 2.3, motor 2 negative terminal connected to port 2.4. That is just assign port pins to the variables or labels. Then coming to the main program. So now let's write the code for run those two motors in the clockwise direction. So in order to rotate in the clockwise direction, we should send the values as 0 and 1. So enable lines are through the hardware line directly which are connected to VCC, so that you no need to write the coding part for enable line. If you want to do that, you can also at that time enable line is also have to be connected to the digital lines, but this time enable line directly connected to the hardware VCC. Then it is not programming, just you are programming input lines only. Okay, to to run the motor we should send the values as a 0 and 1 for 2.1 and 2.0 for first motor. So it is single bit operation, so that we have a statement as single bit uh, set bit set bit of motor 1 positive terminal and clear motor 1 negative terminal. Okay, and in the same fashion set bit motor 1 positive terminal, clear motor 1 negative terminal. That's it. Let's check this program. So this is the code only to run motors in the clockwise direction. Already a project was created. I have taken new file. So write the code, save it, dc1.asm. Yes, the file is added to our source group target. Then compile the program. Check out if any errors are there. Yes, there is no errors. Build, rebuild, and after that create X file. Go to targets, output, enable X file. Then you can give X file name DC motor. So one more time, build and rebuild. So now in the destination path you can find the X file. Come to Protea software, just upload your X file. It is the document actually. 051 DC motor. In the objects you can find X file. Okay, now run the simulation. So only one motor is rotating. Let's find the problem. Yeah, sorry. Set bit motor 2. Okay, it is port 2.2 and this is 2.3. Yeah, now those two motors are running in the clockwise direction. So without delay, continuously you are running the DC motors. or sometimes the system may be hanged. To avoid that, better you give some time delay between the running. Okay, so now let us see. uh, First a few seconds I want to run those two motors in the clockwise direction, and after a few seconds run the motor in the anti-clockwise direction. After that, stop the motor. So for that, let's modify the code. So in the hardware, you connected motor to positive terminal to the 2.2, and this is 2.3. Okay, so after running two motors in the clockwise direction, provide some time delay, a call delay. So we know that how to generate the time delay. You can refer previous classes. A call, absolute call. So theoretically, there is a meaning for the a call and long call and normal call. So absolute call will call the subprogram within the range of 2 power 11. That means 2k. So within the 2 kilobytes, it can call the subroutines. If your subprogram is out of 2 kilobytes, a call will not work out. Okay. So delay, this program needs to be right. Written, and there you can find the session point. So already I have explained how to generate the time delay. I can refer previous classes. Okay. So now here, which are the statements to run the motor in a clockwise direction. After that, after by giving some time delay, we should run in anti-clockwise direction. For anti-clockwise direction, we should send the values in the reverse pattern. So 1 and 0. 2.1 equals to 1, 2.0 equals to 0. So clear motor 1 positive terminal, set bit motor 1 negative terminal. Again we have to provide time delay. So up to the time delay, two motors will start to rotate in the anti-clockwise direction. After that, if you want to stop the motor, two motors, simply by sending zero values. Clear motor 1 positive terminal, clear motor 1 negative terminal, and clear motor 2 positive terminal, clear motor 2 negative terminal. How much time you want to maintain those two motors in the stop? Again here we should provide some time delay. After that, short jump to main, repeat the same series of action. Okay, now it's our code. Let's check out. Somewhere there is syntax error. Set bit motor 1 negative terminal. So run the circuit. Now you can see clockwise, anti-clockwise, and stop. So if you want to see the difference, you should do more time delay. If you want to see the difference, you have to give much time difference. Clockwise, then anti-clockwise. After that, immediately stop it. So stop state is also taking some time. Okay. So as per the program, you're running the motor in a clockwise direction. After some time delay, immediately you're trying to run in the anti-clockwise direction. After a few seconds, you're taking stop mode, which are the statements for the stop the motor. Okay. So it is the program. In another method, we can reduce programming length also. So in this pattern, you can find number of statements. Okay, you can minimize the number of statements in another method. Okay, so what is the first value? 0 1 here for the first motor, 0 1 for the second motor also it is 0 1. Now two motors are running in the clockwise direction. Then you are sending like a 1 0 1 0, then anti-clockwise. Then you are sending all zeros. First stop right now. So if you found, so in terms of hexadecimal, what is this value? 0101. That means it is 5 number, and this value 1010. It means A, and this is 0. Actually, these are the IV lines are motor driver input lines are connected to 2.0, 2.1, 2.2, 2.3. See, this is the 2.0 actually, and this is port 2.1, port 2.2, port 2.3. So directly by sending values to the port 2, you can minimize the number of lines. Okay, so to the port 2, directly you are sending values like a 05, then 0A, then 00. So by sending these values to the port 2, you can control the same action. Let's try this. Let's take second method. Maybe the video length is more. I'm trying to give in detail information. So instead of that, we can avoid the maximum statements. Okay, main program. So initialization completed, then start the code. So as per the table, we should write 05, 0A and 00. move port 2 comma 05 hash 05 h, then a call delay. Next value 08h, then stop the motors. That's it. Same program, I copied here. So uploading X file is one time is enough for you. Just I'm trying to upload one more time. Same action. So clockwise, immediately anti-clockwise, then stop it. If you want to see the difference, again, uh, so just like so, let's modify. So here you are running the motor in the clockwise direction. After that, stop it for some time. To stop the motor, send 00 value to the controller. Okay. So now by writing like this, you are running the motor in the clockwise direction. Here you cannot say. Those two statements are for the running the motor in the clockwise direction. After that, I want to stop it. Okay, I have to send that modification. Now you can see clockwise. Stop it for some time. After that, anti-clockwise. Again, stop for some time. After that, again clockwise. Why? Because our program in the infinite loop. Okay. So in the next session, let us see switches and DC motor. So next session is very interesting. Let's try to prepare a small car, remote car. Okay. Let us see in the next session. Thank you.